Alright, Engineering 10. Today we're going to learn about LDRs. Light dependent, light detecting, but whatever you want to call the D, they are they're resistors that react differently based on light. So some people will say that an LDR is a light detecting resistor, some people say there's a light dependent resistor, but either way, they work the same way. And so we're going to figure out how they work. So the materials for this lab are going to be your breadboard. The LDR should be in your little baggie that I gave you for the summative project. It looks like a tiny solar panel because, well, it's a tiny solar panel. You'll also need an LED, your 9-volt battery, and your battery snap. So this one's a fairly simple little lab. As long as you follow along, you should be able to understand it quite easily. Now, the LDR is a photocell. The schematic symbol looks like this. You can see that it kind of almost looks like the component itself. If you take a close look at the top of your photocell, your LDR, then you'll see that it looks, like it's got little wavy lines, kind of like a solar panel does. And the schematic symbol is really the schematic symbol for a resistor with a circle around it and 2 arrows going in. That indicates the light. Okay, our procedure. We're going to create a series circuit. You should know at this stage what a series circuit is, as opposed to a parallel circuit. A series circuit is where you've created one path for the electrons to flow. A parallel circuit is that you've created multiple paths for the electrons to flow. Easy way to tell is if it's a series circuit and you unplug one component, all components will stop working. So if you've got a whole series of LEDs wired up in series, you unplug one, all LEDs will go out. If you've got them wired up in a parallel circuit, you unplug one of those LEDs and all the other LEDs in the other branches of your parallel circuit will stay lit. Okay, so here's your procedure. You're going to wire up the circuit like this. You should always connect the batteries last. Make sure that you're protecting your components. So you can plug in your battery snaps as shown here. I'm going to show you in Tinkercad as well. Be sure that the long leg of the LED, so the anode of the LED, is getting the positive voltage. And you're probably going to need a jumper wire to connect the LDR to the LED. So this is what it looks like, probably in your world as well, kind of similar to this at least. We've got our 9-volt battery with our battery snaps attached. We have the negative side going into, or attached to the cathode. This is important, obviously. It's got to be on the negative side. The cathode has to get the negative side of the circuit. So we've got our negative terminal plugged into the cathode. We've got our anode connected to our LDR through this little jumper wire. The LDR has no polarity, so it doesn't really matter which way you've got it in. So in this case, on Tinkercad at least, it identifies this leg as terminal 1, this leg as terminal 2. So terminal 1 here is connected through this jumper wire to the anode. Terminal 2 is connected to the positive post of the 9-volt battery. So when I start my simulation, nothing happens. Well, that's kind of annoying, but that's because there's light being shone on my LDR, my photoresistor. So what you will need to do is hold your hand over top of this little photoresistor. I can simulate that by clicking on it here, and in the darkness, check it out. Nothing happens. In the light, though, my LED's on. So what you're probably seeing is, well, when you don't hold your hand over the LDR, over the photocell, then your LED turns on. But when you hold your hand over the photocell, especially when you put it right down on top of it so it gets darkness, then your LED goes off. So in the light, your LED's on. In the darkness, your LED's off. Imagine a night light like that. Imagine a night light when you were a little kid that turned off in the darkness and turned on in the daylight. Well, that's kind of useless. It's kind of nightmare-inducing for little kids who are afraid of the dark. In the dark, it goes off. In the dark, it makes it dark. In the light, it makes it light. And you don't need the light in the light. So it's kind of a ridiculous circuit when it's built like this, isn't it? But it serves the purpose of showing you what an LDR or what a photoresistor does. The photoresistor is a variable resistor that adjusts its resistance based on the amount of light that's being shone onto the photocell. Yeah, so that's our lab right there. Pretty simple. Now, obviously, it's another variable resistor, kind of like the potentiometer. The potentiometer is a variable resistor that allows a different amount of resistance based on turning the dial. An LDR is a variable type of resistor that allows a different type of, or a different quantity of current based on the amount of light that's being applied to it. So the more light, so remember how the LED is on in the daylight? That means that in the light, with more light, you've got a lower resistance. In the darkness, the light goes off, the LED went off. So in the darkness, it's a higher resistance. So dark, so less light, high resistance. High light or more light, low resistance. And that's that lab. You will need an LDR for your summative assignment.